My name is Reagan Prosser. I'm in Katie Long's 9 a.m. class, Tuesdays and Thursdays, ELM 465. In this assignment, we will go over a 6th grade standard in the domain of expressions and equations. The little blurb that it's under is 6EEA. In that, it reads, write and evaluate numerical expressions involving whole number exponents. So I would ask the class, what is an exponent? Think, pair, share, collaborate with your shoulder partner, ask a friend of yours, whoever's near you, what's an exponent? So it could collaborate. Then I would ask the class, what is an exponent? Someone raise their hand and tell me, blah, blah, blah. And then we would go over it. I would write it just like this. I would explain that your normal number is called your base number. And then your exponent is kind of like the little cape-looking thing that's on kind of the corner of a number, and that's called your exponent. We would go over that. We'd talk about it, why it is that way. And then we would solve it. So 3 to the power of 4. How we would solve that is repeated multiplication. So we would do 3 times 3 times 3 times 3. Repeated multiplication. So I know 3 times 3. 3, 6, 9 is 9. So 9 times 9 is 9, 18, 27, 36, 45, 54, 63, 72, 81. Little math songs I learned in 2nd grade. I will definitely be using those. 81. 3 to the power of 4 is 81. Or 3 to the exponent of 4 is 81. And then we will go over a couple more examples. This is what I would do for the kids at grade level. The students that need more help, I would pull into a small group. I would explain why we use repeated multiplication. Maybe they're struggling with multiplication, so we would just go over that more. So again, this is the at grade level, and this is just another problem I'd use. Is like 4 to the exponent of 2, 4 to the power of 2. We would do repeated multiplication, so 4 times 4, 4 times 4, 4, 8, 12, 16. 4 to the power of 2 is 16. We did the exponent of 4, we did the exponent of 2. Let's do the exponent of 3. We would do 5 to the exponent of 3. Repeated multiplication, 5 times 5 times 5. 5, 10, 15, 20, 25. 5 times 5 is 25. We could do 25 times 5. We could set it up just a little bit differently. And then we could look at it a little bit easier. 5 times 5 is 25. We already said that. And then we go diagonal. 5 times 2 is 10. Plus 2 is 12. 125 would be my answer for 5 to the power of 3. Or 5 to the exponent of 3. We did exponents 4, 2, and 3. We could do exponent to the power of 1. I wouldn't go over the exponent to the power of 0 just because I feel like that would be so confusing. So how you would do this is the base 6 times the exponent 1 time. 6 times 6 itself, right? 6 1 time is just 6. So anything to the power of 1 is itself. And then some challenge problems I wrote down for some students that are just above and beyond include and I could have a whole worksheet of this too. 7 to the power of 3 just because they're bigger numbers. So it would be 7 times 7 times 7, which would be what? 49 times 3, so just a little bit more complicated. 9 times 9 times 9 times 9, so what? 81 times 81, so a double multiplication problem, just a little bit more complicated. This is just a couple more steps. 11 to the power of 1 plus 3, so we'd have to solve that first, being 4, and then 11 to the power of 4. Same thing here, but subtraction. This is what I would do. This is how I would teach it. Again, 6th grade math standard, expressions and equations. Thank you for your time. I hope you enjoyed.